This is Ed Robinson. Continuing on talking about functions, we'll now discuss variable scope. The scope of a variable is where it's recognized. So let's take a look at this code, and we could run this code. The output is 1 and 2 as we would expect. So we've got I here and j here, and printing out the I and j in each of these functions. But what if I try to do something like this? If I moved this up as well and tried to refer to j, well, it won't even compile. If we were to try and build that, we'd get an error, but you can see it's showing an error already. The name j does not exist in the current context. Well, that's because when we declare a variable like here, it's only declared within that particular area, which is in this case a function. And when we declare I here, we're only declaring it within that particular function in this case, so that j is definitely not known inside this function. So we say that I and j are local to their particular function. So this variable I is local to this function here, and this variable j is local to this function here. This is the scope of I and j. The scope of I is this function, and the scope of j is this function. We could get rid of this for a start, but we could even call this I, on the understanding that they are completely separate variables because they've been declared locally. So if I run this, you'll see it will indeed work and produce the 1 and the 2 as it did before. I rather think of this particular I here as being colored, say, red, and this one here being colored as blue. So they are completely different variables, independent. Well, then you might say, well, why don't we declare the variable outside? And to do that, we give it the notation of static int I, for example, and then we don't need a declaration down here, so I'll get rid of this and then get rid of this. Now, are they independent variables? Absolutely not. They're one and the same thing throughout the whole program. So this I, if you like, permeates the whole program, and if you change one, it will change it throughout the whole program. Now you might say, hey, this is great. I'm going to use static all the time, because why should I be bothered in declaring every time? It's a nuisance. Well, it's because it can if errors occur, then you won't really know where the error occurs. If it's you change a variable here and you don't know how it affects other parts of the program. And remember, the code might be thousands of lines long, and so it's a good idea. In fact, don't do it. Don't declare your variables externally, so to speak, outside the main as static variables. Make sure you always declare them inside the functions as locally as possible, like this, for example. I know it's a bit of a nuisance, but it will pay off in the long run. Since we've been talking about functions, let's consider how we might pass a structure to a function. Well, we've created our structure in the usual way here. We've created an instance of the structure and we've assigned it values. How would we pass the structure to a function? Well, we want to call a function something like this. We're passing the actual structure itself, passing an instance or passing an object. So we need to therefore create a function which would accept that structure, which might look something like this. Notice that we use the word static as we do with a standalone function, which is what we've been talking about. It won't be returning anything. This is the name of the function, and you can see that this is the parameter which receives the value of p1, and then we could write out any of the elements that we like within the structure, within the function, I should say. So if we do that, you'll see the value of 2 is written out. As an exercise, you might try writing out the value of s. We could also pass a structure by reference, and that's very simply achieved by putting in the word ref here, as we've seen before, and then ref to pass the actual instance. the exercise, to see the difference, we might actually increase the value of I for this particular object. Not P1, it's P which is being passed, and then we might increment it and then write its value out. Well, nothing unusual there. It should just increment the value, but you'll see that it's changed to 3, but you will find that it's been changed permanently. So you might like to single step this and go back and look at this value here, p1.i, and you should find that it does get changed permanently because you're passing by reference. Also, for some practice, we might like to try and return our structure. And in order to do that, we'd have to change the return type, which is going to be a part object. We might then like to put that equal to a new part object, and I guess we could just write out the value of P3's I, and for a change we could perhaps run it using a breakpoint. And if I run that, then I can take a look at the object here, P1, it's been initialized, and then I can F11 to single step, and you can see that it's being passed to P, and indeed take a look at P, you can see it's been passed, the elements have been passed, and then I can increment just the I value, and then I can take a look at P, which is obviously is that, and now that's returned. Where is it returned? It's returned ultimately to P3. P3 at the moment has not been initialized, but if I now press F11, you'll see that it is, and it contains those two values, and then we simply write them out. Let's talk about some other bits and pieces with functions. For example, optional arguments. You can take a look at this code. It simply passes the value of 3 to I and prints the value out. Let's just run that, make sure that's working. So that gives us the value of 3. Okay, but what if we don't put an argument in here at all? That we forget perhaps, and we try to build up, but you can see already it's complaining because it doesn't have any argument. It's not consistent at all. C# has picked up that error, if you like. So what we can do, which is fairly new to C#, is that we can place an optional argument in here. So if you don't, you see that's gone unread, so that if you don't use an argument, it will use this argument as an optional argument. So when we run that, it simply gives us the value of 10. Lastly, let's talk about refactoring. Refactoring is when it produces functions for you automatically. Let's say I've got some code here. Let's say that I want to put this code in a function. Well, it's not much code, is it? But you might have, hundreds of lines here. And that's how you might go about developing programs in general. You'd write lots of code like this, and then you put that particular bit of code into a function. But C# can do it for us automatically. What we do is simply right-click on it and choose refactor. And then here it says extract method, which I will do. So if I extract a method, and then I'll give my method a name. So my method, and then click OK, and look what happens. Isn't that amazing? It's put all of my code, hello, one line, but it could be hundreds, into a method automatically for me. It's given me the right return type and so on. Return type, sorry, is here. And we've used the word static, which means it's a standalone method. So if I just run that, you'll see that C# has been very clever and made a function for me.